Hello and welcome to the Observe section of the Digital Operations Workshop. Here we'll take a look at what we've deployed into our cloud environment, and we'll see how data flows from our edge devices into a data lake where we query it. Now first, to help with the mental model, let me show some common components I see when interacting with our customers around their OT environment. So first, we have our sensors, so the place at which something is measured in the field. And then we often see those measurements reaching a message broker. So this can be something on the edge, which can be great for really high volume messages, or this can be in the cloud, which is great for integration with our whole cloud ecosystem with a minimal edge footprint. We also have streaming services, which is where we'll first persist our messages. And again, on the edge, we can have a streaming service. If we want to have a very high volume data pipeline, that can be a way to optimize our network usage. Or we can also have these systems in the cloud, which can make it easy to manage and integrate with other services. Now, once we have our messages persisted in a streaming service, we can load it into a variety of systems. And the way I think about this is there's basically three types of data stores we can look at loading the data into, and the right one for your use case depends on your business context. So we can store aggregations of our streaming data in memory if we want to serve it in a one-to-many way with very high performance. In this way, we minimize the read complexity by computing the aggregations at write time. In this way, you can have a very high volume stream that will materialize a view in memory and then serve it to your end users in a performant way. Now, if you want a bit more flexibility and we can sacrifice a bit of latency when serving the data to customers, we can look at disk-based storages. And this is actually my recommendation for where you should start, because this is a great flexible way of storing the data where you can do things like make queries against the data to investigate what's there, and you can serve it to dashboards in a very high performant way. You only lose tens of milliseconds in read performance until you're at very high volumes. And finally, there's the object store, which is an excellent place for analytics, where you can have very high volume streams, land data in your object store, where you can then run analytics on top, run reporting, train machine learning models. It's a place where, because the storage mechanism scales so well, you can store large amounts of data to use in other kinds of applications. Let's take a look at what we deployed in this workshop in order to see how that works together. So here is an overall architecture of what we've deployed. Now, in this Observe section, we'll go through the path on the left here, where here we have an IoT device, which in our workshop is an EC2 instance, but it's in a separate VPC, so there's no networking connection between it and the rest of the cloud environment. It's simulating, if you had a real device in the field, what the interaction between it might look like with your cloud environment. And here, we'll first take the analytic path, where we'll optimize for reporting and training machine learning models and this kind of thing on top of an object store type of storage system. So in this pattern, the sensor readings occur in the EC2 instance in our IoT device, and then it will connect to IoT Core, which is used for our message broker, and we can use the rules engine to then do several different things with it. But here, we'll just talk about consuming it from an Amazon data Firehose, which will allow you to emit the data into an Iceberg table, which is a type of open table format data lake table. So this is an excellent way to store high volume data. Then once it's in our Iceberg table, we can query it with Amazon Athena in order to interact with that data. So let's take a look at what that looks like in these steps. First, let's look at how we provision our devices. So in the previous example, we showed these EC2 instances acting as IoT Core devices. How does that work? How do we make the connection between our edge device and IoT Core? Well, there are 4 provisioning ways that are common. So I'll talk a bit about each one of these. The first one is where people usually start, where I'm going to provision a single thing in a lab environment to test out what it looks like when I interact with IoT Core from my device. So what you can do is use a service called AWS IoT CA in order to provision a certificate for the device. You will load that certificate onto the device, and the device can then use it to interact with IoT Core. Now, this is great for getting started, but this does mean that the environment that you build the device in, so the factory that will produce the device, must have access to your AWS environment because it'll have to ship the certificates that have authentication against your AWS environment. So that's why it works well for these small batch ones where you're in your lab creating the connection. But usually at production, we don't do this because we like to impose trust barriers where the factory floor doesn't have access to our AWS environment. We'll talk about more later how to optimize around that. The second way is provision by trusted user. So here, when the device is shipped, it won't contain a certificate at all. It'll just have some kind of mechanism for a user to interact with the device. So this is a very common way for end user IoT devices where when the user receives the device, there's typically an app where I'll authenticate. So maybe username, password, and then the app can be confident who I am. And then my user is able to provision the certificate for the device. So I'll typically make some kind of connection to the device, and then the app will have some flow where the certificate will be provisioned and then will be loaded onto the device. The device will then use that certificate to interact with IoT Core. Now, if we don't want to have a trusted user involved, we can do several other provisioning mechanisms. So one is provisioning by claim. So here, when you ship the device from the factory, it will have a certificate on all the devices that's the same certificate. The certificate will basically enable the device to provision itself. So from the factory, it'll leave with a certificate, and then typically on the first internet connection, once the device is deployed, it will then use that certificate to authenticate with AWS, and it will then be able to provision its own certificate so that the device will end up with its own unique certificate that it'll use for communication with IoT Core. The batch of devices provisioned from the factory will all come with the same certificate, but it'll only be used to provision the device. And so that shared certificate per batch at the factory will only be used one time for provisioning. And you can have hooks into your provisioning flow to do things like verify the IP address of the device or make other checks before you allow the device to provision itself using a shared certificate. The fourth way is a very common way we see, where just-in-time provisioning, where here the factory floor will provision a certificate that's unique to the device. So each device leaves with its own certificate, and you'll create a trust relationship between that certificate and your AWS environment in order to verify that when a device holding that certificate presents itself, then it will be granted the permissions to use AWS services like IoT Core. So the device here leaves the factory with its own unique certificate that never changes. So the private key never enters the device outside of the factory. The trusted factory environment is the only place where that private key will move. And the device will be able to leverage that in order to interact with AWS through that trust relationship. So those are 4 ways that you can provision devices. The other text in this block goes a bit more in detail about those options. Here in our workshop, we are using the provision by single thing manual option, where because I'm vending these these IoT things inside my AWS environment, I can leverage that connection in order to, at build time, provision those certificates and add them to the devices. So the way this works here is the EC2 instance in their user data will go through the flow of provisioning that IoT certificate that it'll then use to interact with IoT Core. Great, so let's take a look at what data looks like moving through the console after you've done that. So here's our console tour section. And here, first, let's look at data coming into IoT Core in AWS. So I am in my workshop slot 1, so I'll copy this subscription filter, and I'll navigate to the AWS MQTT test client, where I can then check out the messages coming into my environment. So if I come here, I can paste my topic filter. So the way this works is when you publish MQTT messages to IoT Core, they come in with a topic. And so here, I can filter to just messages coming in from the IoT devices from my deployment. And all of those messages will come in looking like Edge, slot 1, and then I use a pound symbol, which is a catch-all, which will match anything after that string. So I'll get all of the messages from my IoT devices in this way. And here we can see some coming in. So here is the topic that the messages are published to. So here's my EC2 instance ID, and then it's coming into the telemetry from that EC2 instance. And I can see my computer usage, my memory usage, and my disk usage for all of my devices in this way. So we have our data coming from our IoT devices into IoT Core. Now, from there, we can do several things with it. So IoT Core is a great entry point into the AWS environment that we can use IoT rules to do a variety of things with that measurement. And the simplest one to store data for analytic purposes is to put it into a Kinesis data Firehose, which is a managed service, so minimal configuration, and you will configure the Firehose to read from the topic filter you have in mind, and then add the data to an Iceberg table in S3. So if you go to the S3 observation part of the workshop, I can navigate to the S3 bucket that was deployed, and we can see the data coming in here. So here is the root of my Iceberg table. So we can see some metadata and also the data files themselves. If I click on the data files, I can then see Hive style partitions that do several things. They make it clear when I'm navigating the S3 bucket, which files are associated with which partition filters. And when I query the data, I'm able to partition by these filters in order to not scan the actual data, but just use this metadata associated with the object to optimize my queries. So if I go and look at my slot 1 deployment, I can look at my year of 2026, the month of 8. Let's check out the recent data of day 24, maybe hour 17, and here are my data files. So this is what the output of that Kinesis data Firehose looks like, that the data ends up in S3 and Parquet files that are queryable as part of my Iceberg table. Now let's look at what the performance of this system looks like. So if I go to my Athena freshness block, now we can query the data. So the way this works is I'll first open up the Athena console. Now the workshop came with a workshop shared workgroup that we'll use to authenticate when we're querying the data. And then we can do several things. So I'll go ahead and make a new query to show how this works. And first off, on the left, I can see I'm in my workshop telemetry database, and I have my one table, which is my telemetry table. And I can even preview the table here. So I'll just list the top 10 rows, and you can see that same data that we looked at through IoT Core being presented here. Now, if I want to check out the performance of the data coming in this way, I can run this query here, which will show me how fresh the data is coming in through the Kinesis data Firehose. So I can run that query, and it's nicely partitioned against my workshop slot so that it's reasonably performant. That query ran in 3.3 seconds. And I can see that for each of my IoT things, I have under 2 minutes of freshness, which is common. So the interval at which Kinesis data Firehose will write to this Iceberg table is 300 seconds. So I should expect anywhere between maybe 20 and 300 seconds to be how fresh the data is from this piece of the pipeline. So this is not the freshest way to move data into your Amazon environment, but it is excellent for high throughput, and it's very managed, so that this is a very reliable way to end up with high fidelity data in your Amazon account that you can then use for analytics and machine learning workloads. Great, so in this block, we looked at data moving into our Amazon environment from the IoT devices, creating our MQTT messages that go to IoT core, then to our data Firehose, which lands the data in an Iceberg table in S3. We saw the freshness is great or appropriate for machine learning and analytic use cases, but not great for live dashboards. There's some reasons here that you don't typically run low latency dashboards from an Iceberg table because it's built for analytics and not for high freshness data. So in our next section, we'll dive into how we control the messages to modify what's being sent to the pipeline in a performant and managed way where you can leverage Amazon native services to manage your fleet of devices in a reasonable way. So thanks, this is Walt. See you next time.